Do you have a Steven in your family?
I don't know that it's Steven.
Okay, let's take a look right here, folks. So I'm going to ask you to do the same thing that we were doing in the hallway, but this time on paper. I'm giving you a function, derivative, and it is your job to come up with the original function. So let's do this one together. The derivative is quadratic. What must be true about the original function? Okay, so I'm going to start with x to the third. If I take the derivative of x to the third, do I get 3x squared? Okay, so that works. Now, let's suppose there was, say, plus 1 right here. Wouldn't that still give us 3x squared? And if there was a plus 2 right here, that would also work? So what you're going to do is you're going to write a plus c. And that c, you guys might even be able to guess what that stands for. It's a constant. I'm going to call, if you don't mind, I'm going to call this the cat. Because that way, when you forget to do it, I can go like this. It is a fact. Let's continue. We'll do another one together. Okay. This time, we start with an x squared. We say, okay, just like the last problem, that means that the original function must have been an x cubed. Now, if I take the derivative of x cubed, do I get x squared? That would give us, right now, this would give us a 3x squared. So, because this is giving me something that's 3 times more than what I want, I got to put something right here. Nice. Okay, good. Plus, there's a 1 right here. I hear x. Do you guys agree with that? Plus x plus the cat. Okay. I'm going to call on you guys just a little bit as we move into number 3. This one says dy dx, so we would write the original function as y. And Ava, would you be willing to give us a hand with this one right here? It says x to the 4th. What do we know the degree is going to be on the original function? Okay. And then we're going to need a coefficient on this one. So right now, if you took the derivative of x to the 5th, what would that give you? Okay. So since this would be 5x to the 4th, what are we going to need to put right here? Yeah. Okay, cool. So we got that. Plus, Blaze, would you take the next one? Got an x to the 3rd right here. Antiderivative for that?
I would say it's going to be a 1/4 x to the 4th.
Okay, I'll write that down. Folks, does that work? If you take the derivative of that, does that give you this? Meow. Thank you. All right. Let's keep rocking and rolling. We're taking a look at number 4 here. Charlotte, I'm wondering if you could give us a hand with this one. A little bit trickier because it's got that half power on it. But what would we want to do with that half power to get the original function? Okay. And then if we took the derivative of that, that would give us, what, 3/2 x to the 1/2. So, Charlotte, you want to take a shot at what would go right here? Yeah, that works perfectly, folks. If there was a 2/3 here, wouldn't that cancel with the 3/2? Give us the one that we want. Charlotte, anything else? Cool. Keep moving. Let's take a look at number 5. Matt, I'm coming to you on this one. We were given k prime of t, so we want to come up with k of t.
So we start with t to the power of -1.
Okay, I like that. You added 1 to it.
But that would make it like -1, so I have to start off with -1, so multiply to 1.
So you want a -1 in front?
Yeah.
Okay.
Plus c.
Okay. I like it. let's move to the last one. Last one, s prime of t. So we want s of t. That's an s. They never taught you guys cursive? Yeah, that's an s. Like, if I was going to write Evan's name in cursive, I would write this. I did. Hey, on this one, this is just like when you're dealing with derivatives. You don't want to leave it this way. What do you want to do with this before you try to take the antiderivative? What are you thinking, Lucas?
Change it to t to the negative.
You got it. Okay. So now, if we've got a t to the negative 3 right here, we want to knock that up by 1, which would give us negative 2. Good. And then in front, what do we need so that this would be a 1? Yeah. Negative 1/2 times the negative 2 would give you the 1. Okay. Very nice. Okay. One last thing on this. Let's suppose I change one of the problems. Let's change Let's go to the first one right here. Suppose I told you that the derivative is 3x squared and that f of, give me a number. F of 5 is equal to, give me another number.
4.
If you have the derivative and you have a point that's on the function, now you should be able to find the exact equation, which means we can find c. How would we go about that? What would we do? Yeah, so you would say, I know that 6 is equal to 5 raised to the third power plus c. Anyone know 5 to the third?
25.
It is. Therefore, c would be equal to 6 take away 125. Negative 119, which is like the inverse of 911. You don't want to call negative 119. If someone calls 911, you immediately call negative 119 and it cancels it out. It's gone. What was that? We could try.
It's for non-emergencies, so you just tell them good things that happen.
Yeah, what would happen? If
I
you,
thought they would.
I'm trying to imagine
Like,
what.
if you call 199, you can just be like, "Hey, but I just got into college."
You know, this has never dawned on me,
Yeah,
but there's
for
no
the
like
kids.
there's no negative on.
Why would they?
What?
There's
no
negative.
There's no negative.
Negative phone number, can you?
I'm gonna get a negative.
Okay,
There's
good.
a last
What?
one I
You're gonna be the first negative phone number, so you're gonna get 248 negative 1.
I'm gonna get negative 1 just in there. We don't need an area code.
If you need an area code, we don't know where you are. That's boring.
Okay, that would be your answer. Let's do one more of these. I'm gonna go down to number 4, right here. Let's suppose that we know that this function passes through the point. I need to give you an x value. Let's give you 9, comma, give me a y value. 9, 4. Okay. I picked this one out strategically because here's something that you're going to need to be able to do on the performance on Friday. So when we plug this in, we would get 4 equals. By the way, to be clear, there's no antiderivatives. This is what you're going to need to do. Plug the 9 in to the 3/2 power plus c. You're going to need to be able to evaluate something like this. So I know we've gone over it, but let's go over it one last time. What do you deal with first? The number in the numerator or the number in the denominator? Always denominator. And that 2 is telling you to take the square root. So here you would say the square root of 9 is equal to 3. Good. And then the 3 is telling you to cube that. So 9 to the 3/2 would be 3 to the third, which would be 27. Okay. Make sure you know how to do that by hand. 4 is equal to 2/3 of 27 plus c. So that would be 27 divided by 3 is 9 times 2 is 18. So 4 is equal to 18 plus c. Therefore, c is going to be negative 14. Our equation would look like this. Y is 2/3 of x to the 3 halves minus 14. Okay. What kind of questions you guys have? All right. Then flip the page. This should take you about 10 minutes. I want you to work through this, and then when you're done, you're going to get a break. And I'll even get you started on it. Let's use. It says, suppose you throw an apple. I usually bring an apple for this. I forgot today. What is this?
An apple.
It is. This is an apple.
I'm really smart. Why is it?
How is? What do you want it to be in?
Meters per second.
It can be in feet.
Feet are just disgusting.
That's why we wear shoes.
Exactly.
Okay, so I've got an apple here. It says, suppose that I take this apple and I throw it in the air with an initial velocity of 48 feet per second. Also, imagine, this is kind of a stretch for me, but imagine you were 6 feet tall. That's got to be some sweet living. Well, you're sharing a little bit of your height with the rest of us.
It's called communism.
Some of us have last names that literally mean small in another language. Like me. I believe Klein is German for small. Like eine kleine Nachtmusik is a little night music. Anyway, yeah, we're an army. There are Kleins everywhere. We're all short people. Like, to a T. In my family they call me Stretch. My dad's 5'3". All right, here we go. The only reason that this apple is ever going to come back down is because of the force of gravity, the acceleration of gravity, which is this. So I'm throwing my ball up. It goes up. It comes back down. And if you were asked to write an equation for its acceleration, you would say that the only acceleration acting on this apple is gravity. Yeah, so it's equal to negative 32. So apple, acceleration, negative 32. That's that. That's it. Here's how it relates. I now want you to tell me the velocity. So if you were going to take the velocity, physics people, forget everything that MJ has taught you. That shouldn't be hard.
Easy.
If we're going from acceleration to velocity, isn't acceleration the derivative of velocity? So in this direction, we are taking the antiderivative, which means since this is constant, the antiderivative would be linear. So you're going to say it's negative 32t plus c. See, do I have a pencil for my c? I do. Hey, but here's the thing. Don't we have a point on the velocity function? Don't we know that at time 0, the apple is moving 48 feet per second? That's what we were told right here. So what is c going to be?
48.
Okay. MJ's probably given you some equation that's like v is equal to a times t plus v naught. That's that.
Exactly.
Yeah. Yeah, that's just calculus. The only reason that equation exists is calc. Here's one more. I want you to write an equation for the height of the apple. So apple goes up, apple comes back down. So you know that the path is going to look something like this. What kind of equation looks like this? Good, parabola. Now that's perfect because we want to take another antiderivative. Antiderivative of negative 32t. Well, we would have to knock the power up by 1, so this would become a squared. So 2 times what would give us the plus 48 is constant, so the antiderivative would be linear plus, I'll put the c in just for a second, but you guys are right. We know that at time 0, since we are 6 feet tall, c is going to have to be 6. So if MJ gave you some equation that's like height is equal to half of the acceleration times time plus the initial velocity times time plus the initial height. Once again, just calculus. That's something you guys can derive now. Take 5 minutes. I want you to take those 2 questions and use them, or those 3 equations, and use them to answer these 2 questions. Go for it.
It's not like
That was not a good thing.
honestly, I just don't get it. Just throw one.
Really want to.
Change in y when velocity equals 0. That's it. Change in y when velocity equals 0.
So, divide the plus is also y direction.
These two seem
So you got the time when it happens, and now you're going to use that. Yeah, it says determine the maximum height. So it's a parabola, right? So it's this instant right here. That might be right. Well, I just think one. 0. Honestly, if that's right, that's pretty cool. That's it. Comment down below. Leave a like.
You have the last one.
It's 5. It's 3 or 4.
Whatever the fuck it is.
That's you can come up with that yourself.
Yeah, I did actually.
Should be 40.
It's negative.
No, it isn't. It's not because it's how fast.
Yeah, so negative.
That's speed.
That's not.
Could be.
You're on.
You know what? I'll disagree to
Oh.
you could
Oh.
Oh, yeah, get checked.
Man, it's 40 minutes.
I'm not
No,
going
thank
to
you. I'm not gonna
725. Are you under the test?
Well, what you found. This instance. Yeah, if you plug that into the pipe, then that would tell you the type. T is equal to 3. That's 1.5.
What did you say that
Plug 1.5 is T.
for the paint sniffer say
Probably something.
T is 3.
stiff bait?
Speaking from experience.
That's just one of the paint sniffers.
This is the. Do you want whether I'm smarter than this?
Yeah, let me show you the smartest you.
Why is he looking at like such curiosity?
I know,
He's
dude.
like-
That's what's funny. Dude, you
There's
got,
like-
you got something that you sent this and like this is hard, dude. You got something.
It is math class.
Dude, he looks like so like genuinely curious. He's like amazed by what's going on.
That's what it was fun.
Dude, he's like, how is this happening? This is absurd.
This is a quality song.
I've seen better photos. This guy is the one really selling it. Yes. I'm actually gonna put the answers up on the board and talk about it just a little bit.
I need to find the smartest person.
It's obviously me. Okay. Hey, ladies and gentlemen, if you want to check your work, for number 4, did you figure out that the maximum height occurs at this instant right here, where the velocity is 0? So you want to set the velocity equal to 0, and you'll find that that instant occurs at t is equal to 1.5. We got up to there? Plug that back into the height equation, and you'll get that the height is 42 feet. Pretty high flying apple. The second one, it says, how fast is the apple traveling when it hits you on the head? There's a couple different ways to do this. But what I know some of you said is, if this time right here at the maximum is 1.5, then this time where it hits you on the head, because of the symmetry, is going to have to be t equals 3. So you can take 3 and you can plug it into the velocity equation. That'll tell you how fast the apple's going. And it comes out to be negative 48, which kind of makes sense. If it went up at 48 because of the symmetry, it's going to come down at 48 as well. Yeah, Avery?
How do you know when to use the velocity equation instead of like acceleration?
On this one, it was because it said how fast. And so that's like saying, what's the velocity?
Okay. Well, then what would it say if it was asking for acceleration?
It would say, what is the acceleration at the... I don't have a fancier way to put that one. Okay. Any other questions for the good of the group? Okay, why don't you guys take 5, relax for a little bit, and then when we come back, we will do a little bit of reviewing for Friday. Yes, you may.